Hello, welcome to the FRQ of the day. Today we are going to see if we can do the 2011 number 2. So let's read this together and then let's see if we can do it. So on this one it says the table below shows the political party registration by gender of all 500 registered voters in Franklin Township. And so we've got males and females, and we've got party W, party X, party Y. And there's a total of 500 registered voters, and there's that many from W, X, and Y, and there's 300 females, and there's 200 males. A nice two-way table, and it gives us the totals, which is nice. All right, part A, given that a randomly selected registered voter is a male, what is the probability that he's registered for party Y? Part B, among the registered voters of Franklin Township are the events is a male and is registered for party Y independent. Justify your answer based on the probabilities calculated from the table above. And then part C, one way to display the data in the table is to use a segmented bar graph. The following segmented bar graph, constructed from the data in the party registration Franklin Township table, shows party registration distributions for males and females in Franklin Township. So there's the segmented bar graph. Okay, and so then it says this. In Lawrence Township, the proportions of all registered voters for parties W, X, and Y are the same for Franklin Township, and the party registration is independent of gender. Complete the graph below to show the distributions of party registration for gender by gender in Lawrence Township, and then it gives you this graph. So if you want to pause the video here and do A and B, and so there you go, and then pause the video to see if you can figure out the Lawrence Township, which you kind of need to look possibly back up here. So you need to look at that in order to be able to draw that. But anyway, okay. So let's talk about this one. So for this one, we have a two-way table, and it says, all right, given that a randomly selected registered voter is male, what's the probability of their party Y? All right. So given they're male, so it's a conditional distribution. Given it's one of these 200 people. Given it's one of the people in this row, what's the probability of party Y? And so all you have to say is just 48 out of 200. That's it. And that would be showing your work. That's all there is to that. And it says R is among the voters is being a male and registered for party Y independent. Well, there's two independence formulas that you have to know. All right, and so I did it both ways. You could do it one of two ways in essence. So an independence means in essence the occurrence of one is in no way associated with a change in the other one. So in other words, if I told you someone was a male, does that change the probability they're in party Y? Or vice versa, if I told you they're in party Y, does that change the probability of they being male? All right, so kind of the most used independence formula is this. If they're independent, the probability of one times the probability of the other event is equal to the probability of both. So if they're independent, the probability of being male times the probability of party Y would equal to the probability of being a male and being in party Y. And so the probability of male off the table, well, on the table here, there's the probability of male is 200 out of 500. The probability of being in party Y is 168 out of 500. And then the probability of both male and Y, well, that's these 48 people. And so that'd be 48 out of 500. And so you'd multiply that. Those two things are not equal. Therefore, the two events are not independent. And make sure you say it in context. The other way is showing this. If they're independent, the probability of one given the other is just the probability of the first thing. All right. So, and in this case, the probability of them being in party Y given they're male, all right, is 0.24. We found that in part A. All right. Is that equal to the probability of being in party Y in general? And it's not. So therefore, they're not independent. So you could have done either of those. But to me, this is sort of intuitive. I mean, if of all the people, of all the 500 people, the probability they're in party Y is 33.6%. But then if I told you they were male, if I gave you the stipulation, well, they're male, now that probability went down to 24%. So that means they're not independent. The occurrence of one, in essence, changed the probability of the other one occurring. All right, and then part C. All right, so part C says, okay, if in Lawrence County, all the registered voters for W, X, and Y are the same, all right, the proportions are the same as Franklin Township, okay? In other words, okay, in Franklin Township, the proportion for W is 88 out of 500. The proportion in in X is 244 out of 500, and the proportion of Y is 168 out of 500. And that same proportion holds true for Lawrence County. We don't know how many total registered voters they have, all right, but we know they're the same, okay? And so, but then it says the party registration is independent of gender. In other words, it doesn't matter which one you pick, male or female, they have the same proportions of party, same proportion of W, same proportion of X, same proportion of Y. And so what I did here was this, is okay, I showed, well, the proportions are going to be the exact same as they were in Franklin Township. And so it's going to be 17.6% in W, 48.8% in X, and then 33.6% in Y. And gender is independent. They're independent of each other. In other words, they're going to have the same proportions for each gender. So this bar graph is going to be look exactly the same. Whereas this, in Franklin, they were not independent. W was different from the W here, and the X was different here, and then this was different from that. But they're going to be the same if they're independent, the proportions. And so what I did is I just said, well, 17.6%, and I estimated that right down here, and I put that in W, and then I went over to 48.8, and you add those two together, and that's like 60, 7.4, something like that. And so they both went out to the exact same place here, and then the last 33.6% is the same there. So in other words, the bar graph will be exactly the same, for both genders. And so there you go. That's your FRQ of the day. And I thank you for watching the video, and I hope you have a great day. Really miss seeing y'all, and please send me any questions you have.